Onto converting strings to values and vice versa, we're starting by looking at the ValueOfDemo, and in the ValueOfDemo we look at some methods within the float class, and I'll make a point of mentioning other classes or other subclasses within the numbers class that also aid in this conversion. So in this particular example, we'll just look at the float class, then you can get a chance to practice with the rest. So what's happening here, we are within our main method, and there's a condition here to check the arguments, these arguments that are passed in the main method. So these are the arguments you'd pass in when you're running the class, either via the command line, or I'll show you how to do that in IntelliJ. So you pass your arguments, and then you have your arguments length evaluated here, so it should be 2 for it to be true. So if that is matched, if you pass 2 arguments, you should be able to continue on with the line by line. So we have this part here. There is a call to the float class, and we're also making a call to the method within the float class, which is parseFloat. And within the method, we are passing in the argument at index 0. So the first argument, in this case, that's passed in out of the 2. What I'll do is I'll take you to first the numbers class to show you it has several subclasses. So anything we're gonna do within the float class will also be available in byte, it will be available in integer, it will be available in double, and so on. So you're gonna work with float. Now if you find that you want to practice with the others, you can always do that. I'll be very thorough when I'm walking you through the float class up to the scope of the demonstration. So this is the float class, and there are 2 methods in our code. The first method is the parseFloat method. Here the parseFloat method, as you see, has a return type of float, the primitive float value. It's a static method. All these were covered in earlier segments. So the parseFloat method expects a string to be passed in. That's why we are passing a string argument. What it's supposed to return is a float, of course, this one here. And because of that, it's very easy to work with it with the passed in string and store it directly into our float variable. Please note it works the same way as ValueOf, but the difference is with ValueOf down here, and in this case it's this ValueOf because we're expecting a string to be passed in. With ValueOf, it is returning a float object, not the float primitive type. As you're seeing here, this is the actual float instance of the class float. So not really the instance, but the object, because the instance is applicable here. It's going to return a float object, and that float object is what will hold the float value. So keep that in mind. I'm gonna take you back to the code, and then we'll see how we can convert the float object into the float primitive type. So here we go. So if I work with parseInt, as you've seen, the return type allows me to directly, so this is the float class, this is the parseFloat method, and this is the argument of type string, because it's expecting a string. So the first one, and what happens is it's stored that directly into float A. So if I go to this next example of float B, I'm working with ValueOf method. So the ValueOf method is gonna return a float object, right? So up to this point, what we have is a float object. So I will need to make a call to floatValue method to convert that object into a primitive float type, so that I can store it in float B if I want to do it manually. So I'll just come here and show you that too, the other float value here. So float value, and it returns a float value of the float object. So these things are not falling from the sky, they actually exist here, as you're seeing here. It returns a float value from the float object, and that's why we have this. However, in the concept of autoboxing and unboxing that we'll cover later, in that concept I don't have to include the float value. I can just include this as it is. Even though it's giving me a float object, it automatically, the unboxing and autoboxing will occur in the background. So it's not, I don't have to do it manually. My IntelliJ, because it's intelligent, will note that I can convert ValueOf to parseFloat. So you'll continue to see that. But just so you know, these methods all exist to work like that. parseFloat is obviously more efficient because it does the conversion automatically without having to go through the object type. However, the others are also available. So yeah, have a look at that. You can practice later. For example, in this instance, you might it might force your hand to work with valueOf. So some of the instances would expect objects to be returned. For example, if you're working with a collection of type list, as you're seeing here, we'll talk about collections later. So I'm expecting an object float, so I have to obviously add float type or objects that are the float type to my array list, as you're seeing here. So in some instances you might find that valueOf is coming in handy. In some instances, maybe later downstream, you might need to make some conversion working with float value, and in others parseFloat will suffice. So take note of that. Now let's run this. So if I don't meet the length of 2 arguments, what I should expect is this program requires 2 command line arguments. My IntelliJ is big enough, so I don't need this concatenation here. It doesn't look pretty to me. I'll just delete this. You can retain yours. So what I expect to see is this program requires 2 command line arguments. Otherwise, if I pass the right arguments, then I should see the results in the end. So in IntelliJ, you'll need to go at these 3 dots here. That they should be somewhere there, if not exactly there. And then as you click on it, click on edit, and make sure you are under application on this left navigation pane. Select valueOf, and this is where you pass the arguments. So if I pass 1 and click on run, it should tell me the program requires 2 command line arguments. And to avoid passing from this int that I've passed into a float, I'll just pass 1.0 and 1.0. So to make it a float already, then I'll run. Then I'll see the outcome here. So of course 1 plus 1 is 2, 1 minus 1 is 0, and so on and so forth. Very interesting stuff. I'll put this out in the practice so you can try it out with the other classes. As you've seen, there's the byte. There are other number subclasses that you can interact with to have a look at the different parses, the different valueOf, and so on. Moving on to numbers to strings. So we also have many options at this point. If you want to convert a number to a string, you can do that by concatenating the value in using an empty space of a string and storing it in the string like this. Another way is to work with the valueOf from the string class. Please note, this is a different valueOf. It's from the float class. This is string class valueOf. So again, like any subclass of the numbers class, they have valueOf, and as you're seeing here, the string class also has valueOf. We talked about the string class in the previous session. So you can work with valueOf, and then you pass in the int value. Then you can also work with toString. Again, all the other subclasses have the toString method. The reason why you might prefer to work with the valueOf with string or compared to the toString for a particular type, it's because this might be a little bit restrictive if you want to work less flexible if you work with different types, but string valueOf is more inclusive. As you can see, I can work with string valueOf with the int value and string valueOf with the double value, which is not as restrictive. But again, I'll put that in the practice exercise. You can check out more about why you prefer one over the other. And finally, ToStringDemo. This class demonstrates why, or instances in your code where it might be important for you to convert the numbers to string. For example, when you want to manipulate instances such as this, where you have a double here and you want to find out the index of a particular character, so you'd have to convert this to string first before you work with it. So proceeding on to this step to show you that we have string s, and with this we are converting this double into a string first. Why? Because we need to use it at this point here. So we are converting this double to a string, and we are setting an integer to represent the index of the character of this character, the decimal point from that string. from that string of these doubles. So in this case, for example, it would be 8, yeah, it would be 85848, like that. So in that case, we can work with indexOf of the string and store that index as an int here. So that index would be 0, 1, 2, 3, yeah. But coincidentally, or the way it works is those also represents the number of digits before the decimal point, because when you're counting the digits you count from 1, but when you're counting the index you count from 0. Same applies to this math right here. It will be 1, 2, 3, 4, 5, 6, and this represents length 858.48 with index 0, 1, 2, 3, 4, 5. So if I take s length, then it's the whole length, which is 6. Then I subtract dot, and dot here represents the digits before the dot. So we say the digits before the dot is the index value of dot. So 3 minus 3, the dot itself, 1. So you'd have what's remaining, which is 2 digits. That's it. See you on the next one. Have fun practicing. I'll put some practice exercises for you to try out.